So we're going to start today with reviewing some powers of 2. So let's see, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and I mean, we could go all the way. Let's say 12 squared is 144. You might be saying, oh, why are we doing this? It's because we're going to relate this to some fractional exponents today. So, if I said 144 to the 1/2 power, that's going to give us 12. If I did 64 to the 1/2 power, that gives us 8. If I did 36 to the 1/2 power, that gives us 6, because we're kind of thinking what number squared gives us 36. So if I was saying 4 to the 1/2, we're thinking kind of the opposite of it. What power squared gives us 4? Well, that's 2. So there's certain powers of 3 you need to know, like 2 to the 3rd, 2 times 2 times 2 is 8, 3 to the 3rd is 27, 4 to the 3rd is 64. You should probably know 5 to the 3rd is 125. So rather than to the 1/2 powers, this is like saying if we had 27 to the 1/3. So what number cubed gives us 27? Well, that's 3. If we had 64 to the 1/3, what number to the 3rd power gives us 64? That's 4. 125 to the 1/3 would give us 5. Oops, sorry guys. Go away. And then if we had 8 to the 1/3 power, that gives us 2. Powers of 4 that you should know, we should know 2 to the 4th and probably 3 to the 4th. So 2 to the 4th, 2 times 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 2 is 16. 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81. And so we should be able to say, well, 16 to the 1/4 is 2. 81 to the 1/4 is 3. In additional powers, you should know 2 to the 5th. Let's see, we might add some more in there. So 2 to the 5th is 32. So 32 to the 1/5 gives us 2. We might add some more of those as we go through. Now where this is going to come into play today is we're going to be simplifying some expressions here. So here is our radical and our exponent. This is called the index if there's a number out there, and then we might have our exponent. And if we were just to switch it to an exponent, it goes exponent over the index. So for example, you're like, Ms. Husing, why do we need to know these? Because some things you should be able to evaluate without a calculator. For example, 36 to the 1/2. So this is one of those powers that we need to know. So we should be thinking, what number squared gives us 36? So that's 6. We should also be able to evaluate some like 1 over 27 to the 4/3 power. So we know from yesterday that this is 1 to the 4/3 over 27 to the 4/3. Well, 1 to any power is just 1, but we can separate this out into 27 to the 1/3 to the 4th power. So to figure out this inside, what number cubed gives us 27? Well, that's 3. So 1 over 3 to the 4th, which we know is 81. We should be able to simplify ones like, let's see, what if we did 16 to the 3/4 power. Breaking that apart, 16 to the 1/4 to the third. The fourth root of 16 is 2, so 2 to the third equals 8. So it works with these indices too. So if we had the fifth root of 32 squared, 32 squared is awfully large, but we can rewrite it as 32 to the 2/5. Separate that out, 32 to the 1/5 squared. Well, we know 32 to the 1/5 is 2, so 2 squared gives us 4. So today what we're going to work on is simplifying a few more expressions here. So for example, let's say we had to write as a power. And we had the third root of x. Well, that would just be x to the 1/3. That's pretty easy. If we had 1 over the square root of x, well, that's just going to be 1 over x to the 1/2. And if we had the square root of 4x to the 5th, that's going to be 4x to the 5th to the 1/2. So if we distribute, we have 4 to the 1/2, x to the 5/2. And we know 4 to the 1/2, that's square root, or what number squared gives us 4 is 2. So we have 2x to the 5/2. If we had to write as a radical, let's say we had xy to the 3/5. Well, it's that fifth root, but x isn't in it, so the fifth root of y cubed. If we had x squared y cubed to the 1/4, so that's going to be the fourth root of x squared y cubed. And let's see if we had 9x to the 4th y to the 1/2. So this would be the square root of 9x to the 4th y, and we could write the square root of 9 as 3. So 3 times the square root of x to the 4th y. We know we could also look at that and say, whoops, let's see if we can bring that back. Sorry, guys. Hopefully it'll come back up here. All right. All right. So we're going to take a look at simplifying a couple of these. So if we ask you to simplify and we had a fraction, it's kind of a review from yesterday, 6x to the -3 over 2x squared to the 3rd. Well, let's see. 6x to the -3, this becomes 2 to the 3rd x to the 6th. So let's see, 2 to the 3rd is 8, x to the 6th, x to the 3rd. 6 over 8 is 3/4, x to the 9th. If we take a look at another one here, let's say we have the third root of 27x to the 6th. Well, this is really 27x to the 6th to the 1/3. So if we multiply that in, 27 to the 1/3, x to the 6/3. So 27 to the 1/3 is 3. So 3x squared. And the last one we're going to look at, let's say we have 9x squared divided by 16y to the 4th to the negative half. So if we distribute that negative half, 9 to the negative half, x to the negative 2 over 2, 16 to the negative half, y to the negative 4 over 2. And we have negative exponents, so this is 9 to the half, x to the first, 16 to the positive half, y squared. Well, what number squared gives you 16? So 4y squared over 3x.